Next topic is GDPR. GDPR stands for Global Dial Plan Replication. Now, what happens between clusters? We know that within a CUCM cluster, there is intercluster communication, right? So if you have a publisher, you have some subscribers, let's say four subscribers, one publisher, there will be an intracluster communication by default. But for intercluster communication, does that happen if we have a cluster one of CUCM and we have a cluster two of CUCM on site one and site two? Now we want some database to be identical on these two sites. So can there be by default any intercluster communication or intercluster replication? No. The replication of the data happens within a cluster between the publisher and subscriber. So from the publisher, it gets replicated to all the subscribers, but within a cluster, not between different clusters. So that can be done using global dial plan replication. That is a solution to that if we have different sites with different clusters configured or few same clusters configured and we want any replication between these for dial plans, we can do that. Now, overview of dial plan issues in large Cisco Unified Communication Manager deployment. What happens with the dial plan in large environments with CUCM deployment, especially in multi-site? There's no support for using the same SIP URI domain in multi-cluster. Dial plan issues in large CUCM occurs very commonly. Dial plan issues. So that is one thing to be considered. Manually configuring and maintaining the dial plan in each cluster is very time consuming and more administrative work is there. So these are some issues that occurs. Then issues or some considerations also. Call control discovery does not support URI call routing. There is hierarchical solution which add dependency on centralized services like CUCM Session Management Edition does not include PSTN backup. So this is something to note when we are doing the uh, dial plan configuration for large environment. And if we are using the CUCM Session Management Edition, then it does not include the PSTN backup. HT23 Gatekeeper does not support URI call routing and PSTN backup. SIP network service do not support PSTN backup. So here we will see a review of URI call routing in CUCM. As we just saw in the previous example, also we have some users in different sites, different locations. In Sydney, we have two. In London, we have one. We have in San Jose, California, two of the users. Call routing to remote directory URIs via SIP domain route patterns based on URI host portion can be done. So between these sites or different clusters, there is SIP trunk configured, different URIs are being used to make communication. URI call routing issues now. So we have seen that there can be this configuration. We can make communications between these sites using their URIs, but there can be some issues like same domain everywhere. If you're using same domain everywhere, it cannot route based on URI host portion. So in this type of example, what will happen if we have like different locations, different clusters for different locations, and we have users or the URIs being used as the same host portion. In that case, the routing will not happen. The inter-cluster communication or inter-site communication using URI should have different domain or different host portion. That's what the concept of routing is used here. So like when we have to send the packets from one network to another, the two networks cannot have the same subnet, right? So they cannot be a part of the same IP subnet. If that is the case, in that case, the routing will not happen because routing is supposed to be between different networks only. So it routes the information or data from one network to another. So these needs to be different networks. Same way here, the identifier is their domain or the host portion. If that is the same, then what will happen? That will be an issue. So same domain everywhere cannot route based on URI host portion in that case. So here, scalability issues can also occur with numeric call routing. So if you are using numeric call routing, not URI, then in that case, also if you have intersites, what can be the possible issues? Digit manipulation for PSTN backup must exist in intercluster for all cluster. So this configuration you will need to do on all the clusters separately because we are using different clusters. That's what we are considering here for different sites. Different clusters are being used. And if we are doing digit manipulation for PSTN or these configurations, that has to be done on each cluster one by one. There will be no intercluster communication or replication. So there can be some of the configuration, maybe not all, but some of the configuration that we need the same in different clusters. But by default, that replication doesn't work. Each cluster needs the route patterns pointing to all other clusters. We need, let's say, the same route pattern on each cluster. So that is a part of the routing, call routing. So the solution to dial plan issues that we just saw with URI or with numeric or with gateway configuration, with route pattern configuration in the large environment, the solution to it is GDPR. The solution to dial plan issues in large CUCM clusters is global dial plan replication. Now, what it does is dynamic exchange of call routing information. So, with GDPR, we can have a dynamic exchange of call routing information. It supports URI numbers and patterns. It includes PSTN backup information. It supports URI with the same host portion in multiple clusters. So, if we go back and see if we have different sites, different configuration like HT23 or SIP networks, or we have the CUCM session management. What happens? They all does not support PSTN backup. But the new concept that is GDPR does include the PSTN backup information. That is a solution to that problem as well. Interaction between the GDPR and ILS. ILS stands for interdomain label switching, something like that. Sure, we'll check. So GDPR application uses ILS to exchange call routing information. It uses directory URI, numbers, or patterns. ILS network provides exchange of application data across clusters. So this is basically used for the exchange of application data between these clusters. This is like the messenger which is making this replication possible to exchange the call routing information, whether it's a directory URI or numbers or patterns. It supports all of that. We can see ILS network. So ILS network here is for different clusters. We have hub 1, we have hub 2, hub 3, hub here with spokes and without spokes. So this is a full mesh of 3 hub clusters. We can configure a secure communication between clusters using TLS for security with certificates and shared passwords. So we can configure an ILS network here for the replication of the data between different clusters. And to secure them, TLS is used with certificates or shared passwords. ILS network synchronization, it uses a full synchronization mechanism. So it is pulled by the other clusters. So like if you make one as a primary and others as a secondary or like server client, so the client nodes will pull the synchronization. So spokes pull from their hubs. So usually we make like hubs works as servers and spokes as the clients, and the clients are the ones, the spokes are the ones that pulls the uh, configuration or the information from the hubs. The hubs pull from their spokes and from other hubs also. So we can also make hubs pull the configuration from spokes and other hubs, and spokes pull from their hubs. So here we can see different spoke hub communication that can happen and synchronization that can happen between spokes and hubs. Information exchange by ILS. We can see information exchange can be directory URI with PSTN failover numbers, directory URI with PSTN failover numbers for different patterns, URI with PSTN failover numbers for either case numbers or URIs or standard numbers, E.164 numbers. Same way on the other side, it shows the same for URI, failover for PSTN, or numeric, and so on. So for this information exchange, cluster ID, route string, these needs to be configured, and using this, they exchange their information of the cluster ID, route string, and they communicate to each other and form the replication. Call routing based on route string. So route string here is, for example, this on one cluster like SJC and London, San Jose and London.example.com. Two of the route strings are there. Now you can manually configure step route patterns, route lists, route groups, and step trunks between these two, and they are sharing their information with one another. And this is how they are exchanging the information. That's what ILS does. And all the information that is being learned will be replicated to each other. Management of learned information. So we can have enterprise numbers with urgent priority. We can set them into partitions for calling privilege. We can use E.164 numbers as urgent priority partitions. We can use enterprise patterns for partitions. We can use urgent priority for fixed length. We can use urgent priority for variable length. E.164 patterns and numbers both can be used for partitions, and patterns can be used for urgent priority for fixed length. And URIs, there is no partition, no urgent priority. Blocking of calls to learned patterns. Blocked patterns can be pattern, prefix, cluster ID, and pattern type. These can be used for blocking any patterns. You can use a pattern, prefix, cluster, ID, or pattern types. Based on these information, we can perform blocking of calls to learned patterns. Import and export of call routing information. So for import and export of call routing information, import dial-pan catalogs from CUCM. CSV file is used for that purpose. Either you can upload, download CUCM administration CSV file, manually created or edited, exported from other systems. Export directory URIs and patterns using bulk administrative tools. URI call routing, we can see, is user portion of URI numeric. If yes, it does host portion of URI match IP address of a cluster number or FQDN. It will check if the host portion of URI matches the IP address of a cluster member. If yes, it will go ahead and check if it does user portion of URI matches on the entry of any accessible partition of that number in the routing table. If yes, it will route to the matched entry of the numbered call routing table, including the GDPR learned numbers and patterns. And if it matches in the GDPR information, it will check if it does user portion of URI match on the entry in any accessible partition or numbered call routing table. So basically what it wants to say or represent here is, for a new URI, either numeric, if it exists, it will go ahead and check if the URI that matches the IP address or the cluster member, and it will check in the routing table or in as per the route pattern configured, and it will take the necessary action based on that. And if not, if the URI does not match, it will check if the URI match a local entry in the accessible partition of the URI call routing table. If it does, it will route to the associated line of the local phone. So that would be within the local network. And if that doesn't match, then it will check if the URI match the GDPR learned directory URI. If it does, it will check if the route string of the match directory URI matches the set route pattern in accessible partition, and based on that, it will perform the routing, and it will route using the step route pattern in that case. So this simply shows the flow of the call routing using URI in numeric and FQDN. Numeric call routing does called number match an entry in accessible partition. Now it will check if, let's say, a user 1001 is making an international call to the number +91, let's suppose, with XXX, any number, an international call. For the called number, it will check if that matches an entry in accessible partition of the number call routing table. If no, it will just simply fail. If the partition does not match, it will fail it there, and if it does, it will check if the matched entry in the GDPR learned entry is there. If no, the route using matched non-GDPR entry. And if yes, it does, it check if it does route string of match GDPR learned entry match a SIP route. And if matches a SIP route, it will go ahead and route using matching SIP route pattern. That is how the call routing using the URI works. Same will be for the domain or FQDN format. GDPR number formats also it supports E.164 directory numbers, E.164 patterns also used for PSTN backup. Globalized call routing can be configured using E.164 directory numbers. Abbreviated dialing using enterprise specific names can be done like URIs, and enterprise patterns can be configured. And GDPR is configured for replication. PSTN backup scenario on net path over intercluster. So here we can see we have an IP WAN and we have a PSTN connection. We can configure PSTN backup here that we will see in the lab. We have two sites, San Jose. We have a routing table that this San Jose site has for different URI patterns and numbers. So there are some numbers, different patterns, and there is a URI. So for which in PSTN failover rule, what is the pattern and what is the number that is configured here? There is a route string. Same way on the other side, we have URI patterns or numbers. We have PSTN failover rule, patterns and numbers, and route strings for that. And we have two connections, PSTN and IP WAN. We can configure PSTN backup scenario. We can do a PSTN backup scenario rerouting via PSTN. In any case, let's say IP WAN is down and we want to reroute the information from the PSTN only. So that can be done again in the CUCM between different clusters.